Okay, quiz 10.1, 10.2 to just combined, which is just a chi-square test, a goodness of fit test specifically. Website claims bag of milk chocolate M&Ms contain 30% brown, 20% yellow, 20% red, 10% orange, 10% green, and 10% blue. Does that add up to 100%? Yeah, I guess it does. Okay. I think that's real. I think I looked that up. Anyway, because they're not evenly proportioned in M&M bags, if you ever noticed. So it records the colors of a large sample and presented the result below. Okay. Null and alternative. Unlike the previous ones, this is not based on a parameter. It's based on you trying to describe the concept that the null is that it's going to be as claimed. So this one probably you just go with the generic form, distribution as claimed. Oh, I mean, you can be specific, distribution of M&M colors as claimed, meaning the null is that you do have 30% brown, 20% yellow, and whatever they said are the proportions. And HA is the distribution is not as claimed. Or something to that effect. So it's not an equation or an inequality, it's more just whether these proportions line up with what they're supposed to according to the claim. Okay, so that's good enough. 2, calculate the test statistics. So now you will know that you have your Z1, which is for proportions. Should have wrote it down earlier. You have your T1, which is for means. And they have the distribution for all of these. That one is N01. That one is T with N minus 1 degrees superior. And you have a third one, and if you take a higher, more advanced stats course, there will be more of these, in fact. But this is going to be the last one that we do. Chi-squared is equal to, and this one is for checking if a distribution of categories is matching up with a claimed distribution. It has a chi-squared distribution with k minus 1 degrees of freedom. So testing for the proportions, testing for the means, testing for a distribution being as claimed or lining up with some sort of proportion. That's the one we're doing. So we're doing the chi-squared, if you didn't already know that. But yeah. So that's what I have to do. You're given that formula on your formula sheet. You're also given your notes because we're taking our exams at home nowadays. But in a real, no, I don't say real, in a face-to-face class, if we didn't have this issue going on in the world right now, you would have your formula sheet only to go with, and you'd have to remember what O and E are on your own, also what the K is, but you can look up your notes, obviously. So anyway, O, E, I'm going to do it baby steps. I got lazy last time, I think, but had a good night's sleep, so I'm willing to take an extra step here. But you don't have to. You can skip O and E, and you can go straight to that if you're comfortable. By all means, I just do want to make sure that nobody's completely lost when I do too much at once. Okay, so I'm going to do the O minus E squared first, and then take that result and just divide it by E. All right, now the O stands for observed. The observed frequencies of M&M colors in our sample. So I'm going to grab that off the sheet. 126, 68. 81, 23, 31, and 33. And if I want, I put them in the order that they gave it to us in, but if I want, I can add little colors just so I know what row is what row. I probably won't need it, but for your purposes of me doing it in front of you guys, maybe it's better if I write brown is the first row, yellow, then red. And actually, that's going to be useful because I don't need to worry about these being in proportion to what they claim, so it will help me to keep track of which one's which. I'm covering small and half-assed though, so hopefully that's enough. Let me see if that's legible. Yeah, you can make it out. Okay. Anyway, my table's all messed up too. happy with it, but whatever. Okay. We will need to find the expected. The expected being based on the proportions they gave us. We basically want to take our entire sample of M&Ms, the actual count, and figure out what 30% of that is, then 20%, and then 20%, and then 10%. So based on those proportions that are given. Did it give us a total? No. So we got to total this up ourselves. We got to figure out how many M&Ms are in our sample. That's our N, whatever I get when I sum L1 after I put my data into L1, which I did not. 126, 68, 81, 3, 31, and 33. What am I doing? Summing L1. 362, so there's 362 M&Ms in my sample. That's your total M&Ms. That's N in when we need it. Do we need it? Not here, but we will need it for this next step, the expecteds. So the idea now, sorry, I'm going to do it one more time because I don't remember that number. All right, 362. Okay, so what we're, the E stands for expected. And I'm going to erase this a little bit because I'm going to write little notes here before I make my entire table. But the main piece, E's, we got to fill these in. Okay, how many M&Ms are there? 1, 2, 3, 4, 5, 6. 6 categories of M&Ms. By the way, that means that's your K. K is 6. 1, 2, 3, 4, 5, 6. Okay, I'm going to say this is not our actual problem that we're dealing with. But let's say it said they were evenly distributed. This is just a hypothetical that I'm going to go through real quick. Just in case your final has a situation that's where they say the colors are evenly distributed. Evenly distributed would mean that you have the exact same proportions of every single one. You wouldn't know what that proportion is unless you work it out. So if it's evenly distributed, then it should be 1/6 in each category, because there are 6 categories. You can calculate what 1/6 is. It's 0.1667 if you do it 4 places. So that's 16.7% should be brown, 16.7% should be yellow, 16.7% should be blue, red, and so on. All should be 16.7% of your total M&Ms. You're looking for this to total 362. Possibly a little bit off of that because of rounding errors. If we round, it might be a little bit off. But apart from that, we should have even numbers, the same number, adding up to 362. And how do you do that? You do your expected formulas, which is just N times P. I want 16.7% of this 362 to be in each category. That's 30 multiplication. It's 0.1667 times over 362. That's going to give us 16%. 16.7%, or sorry, 16.67% of 362. That's how we do percent of something. We did it way back in chapter 1 to make sure we could at least recall and review and refresh our memories about it. But anyway, that percent of 362 is just multiplication by the decimal form. Let me do that. Mind you, this is not our actual problem. I'm aware of that. But I'm going to make sure you're prepared for the final. Okay, so 16.67% of 362, which is 1/6 of it, is 60.3. This one would be 60.3 as well. 60.3 all the way down. If they were evenly distributed, we would expect equal numbers of each. And we had to figure that all on our own with just the term evenly distributed. They didn't give us any percentages at all. We need to know there are 6 categories, know that the proportion in each category is 1 out of 6, figure out what that is in decimal form, use that times 362. You add all those up, and they add up to 361.8. They don't actually add up to 362, but like I said, because of the rounding errors that we are doing, wait, is that right? 6.3. Yeah. Okay. 361.8 is a little bit short because of the rounding errors, which is fine as long as it's roughly that. I know I have that general concept. It shouldn't be like 1,200. It shouldn't be 48, it should be just breaking up that 362 into equal proportions. And again, that can be up because of rounding error. All right. And then we would work from there, building towards this. And that would be how to, that's how we would test if the colors of M&Ms are evenly distributed. That is not our actual problem. They never claimed it was evenly distributed. They claimed that 30% were brown. So I want, out of the 362, I want 30% of that, or I'm expecting 30% of that to be brown. So I'm going to do this same computation again, but this time I want 30% of the 362. So I'm going to multiply 362 by 0.30. That's a decimal form of 30%. That's what n times p is. So I'm going to do that now. 362 times 0.3. 108.6 is what I'm expecting. Okay, next one. I'm just going to reuse that. I'm just going to erase what I need and redo it over here. So now I'm moving into my next category. It's not the same, because again, it's not the same distribution, or the colors are not evenly distributed. So let me look it up. This time, the next category, yellow. They claim 20% of M&M should be yellow. So now I want to do %20 of 362. So I'm going to do 362 times 0.20. I'll get 72.4. Okay, so that's how I'm doing it. I'm going to clean this up a little bit. I'm still going to put little notes. I'm going to use these spaces to put notes for now, but then I'll have to clear it out and make space for my actual computations building up to my chi-squared. Anyway, this one was 362 times 0.30, because it's 30%. This is 362 times 0.20. Next I got 20% red. I don't need to do that again. That will be the same computation as this. So I expect the same numbers of yellow and red because they are both supposed to be 20%, 20%. But this should be more. I'm expecting more because I expect 30% to be brown. Next is 10, 10, 10, all the way down. So this next one is 10% should be orange. Is that right? 10% orange, yeah. All the way down. The last three flavors or colors should have the same amounts. Should be half of this, should be 10% versus 20%. So I'll just do it again. 362 times 0.10, which is 10%. And I got 36.2. Those are my expecteds. Out of 362, 30% of that is 108, and that's what I'm expecting to be brown. 20% of 362 is 72.4, and I'm expecting this to have 20%, this to have 20%. 10% of 362 is 36.2, and I expect orange to have 10, green to have 10, and blue to have 10%. That's the breakdown according to their website. I'm going to erase this, but these are the computations. N times P. P being the proportion or percentage or probability, any of those concepts being interchangeable for these purposes. Okay, now I'm ready to build my table via the list. I'm going to do my O minus E squares, then I'll do my O minus E squares divided by E. I'm going to erase my null because I usually have to write formulas up there and leave myself room, but let me just clear that out. Okay. So my O's, I'm going to be in L1. My E's, I'm going to go ahead and put in L2 right now. And you leave them them as decimals, even though there's no such thing as 108.6 M&Ms. I mean, you could if you chop them, but regardless, whether a people or anything, even if things can only, discrete can only be whole numbers, you still use decimals for more accurate chi-squared at the end. So you definitely incorporate decimals regardless whether it makes sense or not. Alright, I think I'm good. Okay, I'm ready for my L3. Looking at what I need, and again, I'm trying to get to this, and I built it up in baby steps. I did the top, O minus E, and squared. Then I'll divide by E at the end. So I'm going to go in 2 steps to get there. L3, I'm going to go to my column header here, and I'm going to type in a formula that's based on me following this. O is an L1, minus E is an L2. I want to square that expression, squared, and make sure you use parentheses so it knows to subtract first and then square that result, because that's what the formula tells you to do. Parentheses, L1 minus L2 squared. The real 2.76, 19.36, 73.96, 174.24, 27.04, and 10.24. Okay, and basically the closer these are to what they should be, the smaller these are. The smaller those are, and you get a smaller chi-squared. But when these are way apart, far apart, if these are out of whack, then you get a big number here, that gets squared is bigger, and then you end up with a bigger chi-squared. So the more out of whack it is, the bigger chi-squared you're going to get. Let me finish this up. L4, I want to do the actual expression I'm going to be summing. I want the O minus E squared, which I have in L3 already, divided by E, which are in L2. So I'm going to do L3 divided by L2. L3 divided by L2. Okay. I got 2.7878, 0.2674, 1.0215. No, wait, what happened? What happened? Oh, no, I got 3, okay. 4.8133, 0.74696, 0.28287. That's the expression that the formula says to sum, so I'm going to just sum that, and that is my chi-square right there. That is my test statistic. Oops. L4 is where I got it. 17.05. Oh wait, I think I messed it up. I accidentally overwrote it. No, I gotta do it again. I messed up my buttons and then I accidentally typed something else and covered up something. I gotta redo this. L3 minus L, sorry, L3 divided by L2. Okay, 2.7878, okay. .919, so 9.92 I'll say. Okay, that's number 2. A lot of work just to get your test statistic. Next, I want to do my p-value. Alright, so this has a distribution that was given. I just erased it, but it had the chi-squared distribution. So I'm not using normal CDF, I'm not using TCDF. I'm using chi-square CDF with k minus 1 degrees of freedom. K is a number of categories. Don't use 362, it's not n minus 1, that's n. K is a number of categories. 1, 2, 3, 4, 5, 6 categories. So I'm using 5 degrees of freedom in my chi-square CDF. Okay, so K is equal to 6 categories, 6 colors of M&Ms. Those are your categories. Your degrees of freedom are K minus 1, so we're going to use 5. Our chi-squared, 9.92, is somewhere along here. And the p-value is the right tail probability. It is always right tail for chi-squared tests. It doesn't have a left tail. It stops at 0 if you recall. It's not a symmetrical bell-shaped distribution. It is our first right skewed distribution that we're using for hypothesis testing. Anyway, I'm ready to do this. My p-value is equal to chi-squared CDF. My lower bound is 9.92. My upper bound is infinity, 10 to the 99 I'll use, as usual. And my one parameter, degrees of freedom, is 5. Chi-square CDF, you got to scroll a little bit to see it. It's under distribution, the same place you find normal CDF and TCDF, but you got to scroll a little bit to find it, and make sure you're using chi-squared CDF, not PDF. 9.92, 10 to the 99, and 5. I got 0.0775, so I'll do 078. 7.8% probability that you would get things just far out of whack by random chance. So again, to illustrate, if you had, this is the expected, for a sample of 362, you expect it to break down this way. Then you actually grab a handful of 362 M&Ms and you get these proportions, or sorry, these frequencies. And if they're dead on, exactly what you expect, you get a chi-square of 0. If they're very close to each other, you get a chi-square that's a little bit positive. And if they're way far out of whack, you get something way here on the right. So this is an indication, this chi-squared test statistic is a measure of how far out of whack things are. Pretty in line, way out of whack with what they claim. And where's this lie? Is this way out of whack? You can't look at the number and tell. You can look at the p-value and tell. 7.8% chance that this occurred by random chance. Our decision will be based on our significance level. Our significance level here is given as 5%. So it has to be below that for us to reject their claim. It is not below that. All right, so we're not going to reject. We will believe the website, give them the benefit of the doubt, and assume that the proportions are as they claimed, because we did not find sufficient evidence to reject that claim. Anyway, is that just one example of that on one page? Okay. All right, that's it. You could have errors. It's just suppose the colors are as claimed, then HO is true, and you did not reject it, and you look up your errors there. I think I did enough on the homework, and I think I've done enough errors for you to handle it. But if not, text me a question about it. Errors are the trickiest part. For hypothesis in general, this one I do get a lot of, this is the issue, how to do that. You're using those percentages. When I don't give you that and I say it's evenly distributed, sometimes people don't know what to do, even though we've done it twice now. Once in the notes, once kind of half-assed here, so be aware of that. It can be a situation where they don't give you percentages, they just tell you it's evenly distributed, and look up that, or what I did earlier here to remember that. Okay, that's the last quiz. And now it's just the final.